Manika, AP in CSC in SNSInstitutions. Now we are going to see about the data frame. That is, in data link layer, data are represented as zeros and ones. In digital format, we are representing as zeros and ones. Data may be any format, it's video, audio, or any signal format we are representing as a data. So the data must be transmitted as a packet. It's a framing format. We can transfer the packets from source to the destination. So these are all the main thing. That is, in the framing, it's having the in physical layer too. It's connected with data link layer. Then after that, it's connected to the network layer. So in a data link layer, we are specifying how data are specified, how the data are mentioned or taken as in a simple way to transfer the packets. So it's having the header and the packet and the trailer. So header means it's having the address. That is, based on this ID or unique ID or address of map or whatever it is, based on its ID we are transferring where we have to send the data, we have to decide based on this header only. It's nothing but it's the address. So after that's having the frame. It's nothing but packets. It's having certain length of data. It's nothing but the packets. In this data or packets is transmitted to the particular address, and it's having one more field trailer. It's nothing but it's a flag bit. Here, based on this bit, we are detecting the errors. So it's detecting the error. So this is a flag bit. It's having the two types, priority checker and a cyclic redundancy checker. So two types we can detect the errors in the trailer base. So it's a framing is nothing but it's packet. It's having address and a trailer. So it's the main conception of this frame. This is presented in a data link layer. Okay. So it's connecting through the physical layer to network layer through the data link layer. Data link layer we are considering this format as a framing or a packet. It's having a certain function that is detecting and the station detect and detecting the end and handling the errors and framing overhead, then framing efficiency. These are all the things we are considering when we are transferring the packets from source to destination in a certain address format. Okay, so detecting is a main thing is the start of the frame. We have to detect which data and where we have to transfer, we have to detect. In station detect which point on which starting point we have to transfer the packet, we have to decide the station of that particular packets to detect. Then detecting the end where we have to send that particular source packet into destination, we have to detect. So then handling the errors is the main thing, how we have to handle the error. Based on that error we have to rectify, we transferring the packets from source to the destination. In a framing overhead, it's having the address to transmit, that is overheaded, that is over framing or a packets when we are transfer time, that it will lead the over time to transmit the packet, so we have to reduce it. So framing efficiency is nothing but the packet loss and a packet delay and a packet size we have to consider to transfer the packets from the source to the destination. So framing efficiency is nothing but it's maybe a time and a space management. It's nothing but packet delay, packet loss and a packet size, everything we have to consider. So after that, its framing is having certain types. So in first type we are taken as a fixed type. In that one, drawback and a solution type. Then second one is variable size. That is, we have to assign different size of each variable. Next one is bit stuffing. Okay. So in that one, fixed means we have to give the fixed size of packets. So to transfer the packets from source to the destination. It's having the two types, drawback and a solution. In a fixed size manner, more than that size, we can't transfer the packets from source to the destination. So it's having, it's occurred the collision or a error in a certain way because it's overhead, it's overloaded in particular size. So it's in a fixed size, we have to face the overloaded packets. So drawbacks is nothing but it's having certain limit to transfer the packets. Likewise solution, the transfer in a particular packets in a size format in a time-based manner. So variable size is nothing but each and every size we have to assign certain variable values. In that values based we are transferring the packets from source to the destination to avoid the collision. In bit stuffing, each and every bits we are take it as the zeros and ones. Okay, so every data are working as a zeros and ones. So every data transition as a zeros and ones. Okay, we have to transmit these zeros and ones in a certain bit stuffing manner. So in that one, it's having a transfer the packets in a framing format. It's nothing but packets. Okay, these are the main thing in a frame. Thank you.